Yes, sir. आपका presentation अभी now it is visible, sir.
Yes, sir.
Okay. Once again, I welcome all the participants, and I welcome Mr. Dhanas Silvamani from Messrs Kyosan. He will be explaining the practices of cabling and networking in KFA BMC AI installations. So I request Mr. Dhanas Silvamani to start his presentation.
Good afternoon to all. So I am Dhanasala Shivamani. I am a senior manager and taking care of testing and commissioning as well as the system engineering tools. So today we are going to see about the cabling and networking requirement of KFA BMC EA installations. So the agenda for the today is like KFA BMC hardware overview will be there. That is the first. And followed by that centralized and distributed architecture, then designing a cabling requirement for KFA EA, and the outdoor equipments. What are the outdoor equipments going to connected with KFA EA, and what are the indoor equipments going to connect with the KFA EA, and cable requirement for outdoor, cable requirement for indoor, and other requirement networking devices for KFA EA, and a typical cables used in the networking for a VDU, data logger, maintenance PC, protocol converter, EA processor, and etc. And an explanation of one commissioned stations examples will be showing to you. And this outdoor what we are going to explain is more about KFA BMC only. It is not about the outdoor cable and other information. So what are the thing outside the relay room that will be considered as outdoor, not for our signaling cable. Those related, I think, better than us. Railway team knows better than us, since they are using day to day basis. They are using. So we are going to focus only on the KFA BMC point of view. Okay. So that is a point I want to note it down here. And this is a small introduction about KFA BMC. The KFA BMC EA, we have commissioned more than 750 stations in India, and Bangladesh 7 stations, and Nepal 4 stations. So almost we are going to touch 800 in upcoming in this financial year. We'll cross 800. So this is the commission details of KFA BMC in India. All around the world, more than 3,000 commissioning has been done. Station commissioning has done. So first we will go as per the plan agenda. We'll go to the hardware first. So how this section is going to be? This section entire I'll be explaining everything for 1.5 hours, and the last half an hour we'll be doing the question and answer sections. QA sections will be there in the last half an hour or 15 minutes. We'll try to complete this meeting before 5 so that we can able to that is the schedule. As per the schedule, we'll complete before 5 o'clock. So the KFA BMC, the observation for KFA BMC is follows. K is for the Kyosan, 5B is our model number, M for the multimode, and C for the control area network communication protocol. So this is the observation of KFA BMC. So the KFA BMC is having a separate module for logic functioning, vital input output functioning, non-vital input output functioning, and data logger communication. So we will be seeing detailed informations upcoming slide. So it is having separate module for logic functioning, vital IO, non-vital IO, and journal module, and the data logger. So for the this is our KFA BMC modules are available. So LK7C, that is our subrack, logic subrack. Logic subrack is named LK7C subrack, and EP5 subracks are named vital IO subrack is named as a EP5 subrack. EM6 subrack. EM6 subrack is for the panel. Panel non subrack is named as a EM6 subrack. Journal module is for the data logger communication, and the PCNAO INAO card is used for the in the PCs, embedded PCs of operator video and maintenance video. and SPHCTT is our splitter card, communication channel splitter card. SPHCPA is single mode to multi mode converter, and vice versa also it will convert. Vice versa also it is convert. And SPHC PW is a power card for both the DT card and PA card. And other than that, we are using some media converters called FRMC, fiber ring redundant media converter, and some MOXA converters also we are using for the data logger purpose. So these are the overall hardwares which is we are going to use it in a KFA BMC EI. If anybody is having any doubt, you can note it on the chat box. There is a chat box in the presentation. You can drop the message in the chat box. So then and there, you can drop whenever you are getting any questions. The questions can be recorded in the Dropbox. So when we are conducting the QA section, we'll be discussing on that. So So we'll be going to the individual component wise. So the first component what we discussed is LK7C, logic functioning subrack. This is a very vital subrack. So in this we'll check everything. This is the actual subrack. So this is consist of 20 slots. First 10 slot is allotted for the system 1 and second 10 slot is allotted for system 2. In the first two slots, IPU6C is our power supply card that will be installed. So this is a power supply card which will convert 24 volt DC input to 5 volt DC input as well as 24 volt DC input. The 24 volt DC input for the debugging input output purpose, and 5 volt is for the card working purpose. And the next card is CPU card F486 F486-4i. This is our CPU card. This is a two slotted card. IP6C and F486-4i is the two slotted cards. So this is a CPU card which is going to process all our interlocking logics. In this only we will be having interlocking logic. Interlocking logic will be loaded in this IC card for the individual systems, and whatever station specific interface informations will be available in this card. Once again, and FSIO card for the communication card, and FSIO EX card is a fail-safe input-output communication card, fail-safe input-output communication extended card. So this FSIO is having this is for the main communication, and this we can use it for the non-vital communication, video communication. This is for a vital IO communication, and there are some VHSC card. VHSC card is used for the one logic processor to for the communication between the logic subracks. And DID is our station ID, station identification card. So in this card, what we will do will be device identification card. Device identification card. So in this card, will be every station will be allotted with the individual number. Exon number will be allotted, so that the particular station, the station, whatever the station the logic is designed, that will not be useful in the other station. So we can avoid the confusions. So for that purpose, every station will be given as a different XOR number. That XOR number will be hardwired into this card by 25 pin female connector. So for this is the one of the main purpose of the DID, and another purpose is it will act as a synchronization card between system 1 and system 2. Both the systems are getting synchronized through this DID card. And the FIO 7P card, fail-safe input-output card. So this FIO card is a electrical to optical converter card. So FSIO and FIO7. So both the cards are work together to deliver the optical communication, vital communication, as I told. So this card is having three. This card will be having the 5 optical channels. In this, 3 optical channels will be used for the vital communication, and one is for the maintenance PC, and another one is for the reserved. So 5 channels are there. In that, 3 will be used for the IO communication, vital communication, and one is for the maintenance, and another one is restricted. And FSIO EX and EX FIO 7P. These two cards work as a together. This will work as a together card. So this will be there in the front, and this will be there in the back. So the back side, this will be having 3 optical ports. So in that, 2 of them can be used for the VDU A and VDU B, and one is reserved. And HSC sub is again electrical to optical card for the intermediate communication between the logic subrack. This will also work with along with VHSC. VHSC and HSC sub will work as a combined card. So if you see, there are 4 cards are from will be connected from the front side, and 3 or 4 cards will be connected from the back side. So this is the front side, and similarly, this is with the VHSC.
Sir, 1 minute, sir.
Yes.
सर एक्चुअली सभी पार्टिसिपेंट से मैं रिक्वेस्ट करता हूँ कि माइक अपने म्यूट रखें अभी, कुछ बैकग्राउंड नॉइज आ रहा है अभी. ऑल आर रिक्वेस्टेड टू प्लीज कीप देयर माइक म्यूट इन म्यूट मोड एट प्रेजेंट. थैंक्स. ओके सर, यू कैन कंटिन्यू सर.
Yes. So the VHSC cards will be installed like this. So every card will be one card, but when it comes to the VHSC, it will be 2 cards we are installing. Main reason is this is a communication between one large subrack to another large subrack. So we are ensuring that we are making 2 path communication. So the first card will make the right path, and the second card will make the left path. So main path, redundant path, like that we can consider. So every subrack will have a 2 VHSC card and 2 HSC sub card. So this is a backside connection. So this is our IPU6C power supply card. Power. This is the main power we are giving through 1.5 square mm red and black cable. Okay. And remaining, this is our health status monitoring. This is 0.5 mm black color cable. And this is also, these 3 are our fail-safe input-output. Diagnostic purpose we are using it. And this is the DID card. I told you, DID card will be wired with DB 25 pin connector. This is a DID card. So each EXA will be converted into the DID connection, and as per the connection, wiring connection, it will be wired. Okay. And as I explained, FIO 7P, it is having 5 channels. You can see from here 1, 2, 3, 4, 5. So the first 3 will be used for the vital communication, and this is for the MTC communication, and this one is for this is reserved. And similarly, this is also FIO 7P also having 3 channels, as I explained. So this first channel, these first two channels can be used for the VD purpose. The last one is for the reserved. And similarly, HSC sub also having the fiber optical communication connections for the logic subrack to logic subrack. So these are all these FIO 7P ports are made with the FC connector multi-mode cable. FC multi-mode cable will be used, FC to FC. And when it comes to the HSC sub, we'll be using ST single mode converter, single mode connection we are using it. And this is we are using it for the data logger purpose. And apart from that, I explained EP5 subrack. EP5 subrack will have line to be function, line to be, there is a communication come power card and ETPIO2 card. The ETPIO2 will have a ETPIO2 card will have a 32 input, 32 output in individual card. So one subrack we can able to accommodate 5 numbers of VTPIO2 subrack, VTPIO2 card. Similarly, for panel functioning, we are having EM6 subrack. EM6 subrack, in EM6 subrack there are 2 cards, are line M2 and MMIF2. So the line M2 is a power supply plus communication card, and MMIF2 is a 630 32 input and 64 output panel processor card. And zonal module, earlier days we were using the zonal module for the data logger. This is the zonal module. Nowadays we are not using this. We are using direct. We are using it directly from FIO7P. And PCINAO remaining PCINAO, it is used in the PC. So this is the basic overview of KFA BMC. Okay. Now with this multiple subracks, we can make a different system configuration. Next topic is how to make a different system configuration. Majorly, we are using two type of different configuration: is a centralized system configuration and a distributed system configuration. First, we'll be discussing about the centralized system configuration. So this is the convention system configuration used in the signaling system. So in the centralized configuration, both the centralized interlocking unit, that is our logic processing unit, and the electronic terminals, that is our vital input output subrack. So both will be installed in the same room, and field gears are connected to the electronic terminal via relays. This vital I/O subrack will be connected through the relays installed inside the relay room, and the copper cables are used to carry the information from the electronic terminal to the field through the relays and cable terminations. So this is the basic informations about the centralized configuration. So here you can see this is our logic subrack, okay, and this is our vital input output subrack. So this logic subrack is having fiber connection to our input output subrack, vital input output subrack, and further it will be having this is optical, and further input output subrack will have a copper connection to the relay rack. So it will go to the relays. From the relays, it will go to the CTR or FTOT terminals. From the terminals, it will go to the field. This is the basic configuration, centralized configuration. And when the data logger is going to connect, for data logger purpose, we'll be taking it from the we'll be taking it from a splitter. So empty channel will be taken and it will be given to the splitter, and from the splitter, if zonal module is available, it will goes to the splitter. After the splitter, it will convert. It will goes to the protocol converter. From the protocol converter, it will go to the data logger device. There are to connect the data logger with KFA BMC. We got the two approval from the audio. So this is the older method. Zonal module is the older method. Now the new method is external FIO7P is having one serial port. So that I shown here. This serial port will be used for the data logger communication. DB9 serial ports will be used. So that port will be taken and it will give to one serial to optical converter. From there, again it will be again there will be one more serial to optical converter. From there, it will go to the data logger protocol converter. From the protocol converter, it will connect to the data logger. So from the data logger, it will be connected to the data logger PC. And as I told, FIO7P is having for MTC channel, so that channel will be connected directly in the new configuration. And in this session, in this centralized architecture, you have a panel plus VDU. Nowadays, all are dual VDUs, but KFA BMC will support for the both the configuration. So if panel is available, then the logic subrack to panel, it will comes through a multi-mode cable, and from the from our EM6 subrack, it will go to the control cum indication panel. This is one connection, and the panel standby to the panel is VDU. With operator VDU will be the operator VDU also is connected to the logic subrack through the multi-mode cable. So multi-mode cable. So multi-mode cable will from the system 1 system 2, both the connections will come to the operator video, and both the single video will connected with both subrack. So this is a major information about centralized distributor, centralized system configuration. In the centralized system configuration, it is not suitable. It is suitable for the smaller station only, since we have to accommodate all the subracks in only one room. So the room size may be big, and the copper requirement also, since we have to run the copper cable from the central location itself to the field gears, so that main cable, tail cable, the quantity will be more. so that this is the centralized cabin. Since the centralized cabin is there, so we have to provide the repeater relays. If the distance between the cabin and the gear location is more, so these are the main disadvantage of the these are the challenges of the centralized system configuration. So this is the basic system configuration. And when it comes to the distributed distributed configuration, the station yard will be segregated into the multiple zones. Corresponding zones, signaling gears will be controlled by the multiple electronic terminal placed in the different cabin and relay room. So this is the main difference. So centralized processor will be there in central place only, and along with that, centralized processor along with the central electronic terminal, which is controlling the central field gear. So that will be installed in the central location. Remaining all the electronic interlocking ET terminals, electronic terminal will be placed in the different locations, like our Gumtis. Gumti, East Gumti, West Gumti, South Gumti, South cabin or North cabin, whatever we are naming it, it will be placed in a different locations. So I'm going to place a centralized our my logic subrack in one place, central place, and EP5 is in the distributed place. So between these two subrack, I'll be using the single mode optical cable will be used for the communication purpose, and the field gears are connected to the FT electronic terminal via relays. This is also again from the, instead of going from the central place, it will be going from the distributed place. Here also the main copper cable will be reduced from the central to the end cabin, end Gumti, but the Gumti to the location box cables will be there. So this is in this the number of relay buildings should be we need a more relay room, and these are the main challenges in this one. Relay room will be more, instead of in earlier case we will have only one relay room. In this case we will be having 3 or 4 or 5 according to our convenience. We can make the relay rooms, multiple relay rooms, gumtis. And when you are making gumtis more, then power requirement also will be, we have to prepare accordingly. So here also repeaters may require depending upon the location. So here is the distributed system configuration. Here you have two relay huts, relay hut 1 and hut 2, and there is a central room, and there is a SM room, and there is a maintainer room, there is a EA room. So these are the informations are there. So what is the main difference is here is like my logic subrack will same, my EP5 subrack is same. Instead of keeping all EP5 subrack in the same central location, we are distributing into the relay hut 1 and 2. So overall 5 EP5 subracks are there. These 5 we can, if we keep all 5 in one place, that will be like our centralized system configuration. But we are keeping as a different location. So 2 is in hut 1, and 1 is in central room, and another 2 will be in the hut 2. So this is the basic difference between the centralized and distributed. In addition to that, there will be a additional media converter will be used. Since the distance between the relay hut 1 and 2 main central EA room, it will be more typically like 2 to 3 kilometers, 2 to 5 kilometers. So we cannot use lay the single mode multi mode cable. So we have to go for a single mode cable, single mode communication. But the system inbuilt is all the system communications are multi mode. So multi mode to single mode we have to convert. So we will be using the multi mode to single mode converters. So the converter will be used here, and the converter will be used between the communication between relay hut to central location. That is only the additional informations will come when it comes, when you have to prepare for the centralized interlocking and distributed interlocking. And remaining data logger communication, relay room communication, SM room communication, video communication, panel communication, remaining things are same. And since the hut is divided, so half of the relay rack will go to the respective relay rack will go to the hut 1 and respective relay rack go to the hut 2. So once the respective relay rack will be connected to that CT rack, and from there it will control the particular area signaling gears. And this will control some of the signal gears which is available in the central place, and this hut will be controlling gears from the hut 2. So this is the main difference between the centralized and distributed. In a centralized configuration, you don't need this fiber optical single mode fiber optical cable. Installation is not required. But when it comes for the distributed, you have to lay additionally this single mode fiber optical cable also to be laid. So apart from that, our system is equipped to configure the auto block configuration also it is supporting. So for example, in one location you can keep, and from there you can control multiple locations. For example, in this configuration, if you see this red box, so it is controlling the 5 different locations from one central. So this is also again a different. It is a advanced version of distributed interlocking. So as I explained, the different cable informations. So you can see like multi-mode OFC cable, multi-mode OFC patch cards we are using between our logic subrack to EP5 subrack, our vital OC we explained, no? And the multi-mode OFC patch cards we are using between LK7C subrack to EM6 panel processor, and multi-mode OFC patch cards are using LK7C subrack to zonal module data logger, and multi-mode OFC LK7C subrack to operator video to the PCNAO card, and a multi-mode OFC with OFC card patch card we are using LKC our logic subrack to MTC. So you can see from all logic subrack to our internal cards, either it can be EP5 subrack or EM6 subrack or data logger or operator video or MTC or splitter. Everything is connected through multi-mode only. So usually we are planning to buy multi-mode patch cards of 3 meter, 5 meter or 25 meters depending upon the placement of the racks. And this is common irrespective of centralized interlocking or distributed interlocking. This is common. So when you design for the KFA BMC cabling, so you have to consider mainly this multi-mode patch cards. This is the main informations we have to calculate. And apart from this, when it is comes for the distributed interlocking, then we have to use the single mode patch cards as well as a single mode outdoor cable. Single mode 24 core outdoor cable we have to use. So this will be used between the central EA room to ND cabins. So for the central EA to distributed central logic subrack to ND cabin EP subrack. So that is in that information you have to use this single mode OFC cable, and single mode OFC cable also we are using it for the MTC networking. For example, you want to do the MTC, all the like you have some project for 10 station in one structure, and all the 10 station can be monitored from the headquarters or zonal headquarters, or wherever you are saying from whatever the office you can able to easily monitor. So for that we have option called MTC networking. So the MTC networking we can use two options. Either we can use the E1 network or we can use a single mode OFC cable. And single mode OFC cable we have to use it for the data logger networking also. So this is our recommendation, but they are using some of the place quad cable also they are using. It is according to their information. So now I'll explain this cable in the system configuration. So this is our system configuration. If you see this green color and blue color, these are the single mode outdoor cables. Single mode outdoor cables. So if you see single mode cables are used between centralized location to relay hut. So this is a outdoor cable. But when it comes to the patch card, the brown colors are single mode patch cards, multi-mode patch card. Sorry, brown colors are multi-mode patch cards. Okay, you can see that. And the pink, this blue colors also multi-mode patch cards. So MTC is connected to MTC also connected again with the multi-mode patch card. Data logger also communicated with the multi-mode patch card. So from the data logger to this is Ethernet or serial, they are using it according to their convenience. So these are the main cabling details when it comes. Since KFA BMC is completely OFC based, so when we are planning for the cabling, you have to consider this. Along apart from that, there is a power cable requirement. Apart from this, if you see power cable, we'll be using 1.5 square power cable for our logic subrack power and EP5 subrack power and EM6 subrack power, data logger power. And remaining is SPHCT, SPHCBA, remaining and all, it will be used with zero point 0.5 square this one zero point 0.5 square cables. So next topic is equipment to be connected in outdoor with KFA BMC. As you know that KFA BMC can able to control all the outdoor equipment, all the outdoor gears. So the mainly the first is signal. So all the signals can be driven from the KFA BMC. KFA BMC will have a logic subrack. In the logic subrack, it will go to the EP subrack, EP5 subrack. From the EP5 subrack, it will go to the via cable. It will connect it to the signal. Similarly, it can connect it to the point. It can connect it to the track, and it can connect it to the block instrument, and it can connect it to the level crossing, crank handle, start circuit, axle counter. If any other informations also it is required, we can able to connect. So this is the basic equipment to be connected outdoor. Okay. Now we'll see the equipments to be connected in indoor with KFA BMC. So this is our logic subrack LK7C. So this is our EP5 subrack, EM6 subrack for the panel processor. If panel is there, then it will be connected. And this is our electronic terminal for a vital input output subrack, EP5 subrack. And after the EP5 subrack, you have a relay rack and CT rack, and after that it will connect it to the field. And operator video will be connected through PCI or INIO card. And after that, you have a maintenance terminal. Maintenance PC will be connected to the system logic subrack via PCNIO card, INIO card, and data logger. Last is data logger. So these all communications are done with OFC. You can see from this. So all the communication between logic subrack to panel processor plus vital input output processor, data logger, MTC, maintenance terminal, and operator terminal, everything is controlled via OFC. and panel processor EM6 to panel and EP5 to relays and relays to CT rack and CTR rack to field. These are all parallel wiring. So now we'll go to the outdoor cable requirement outdoor in this KFA BMC EA installation guidelines. Okay. So first we need to understand for the earthing. So you all are know that KFA BMC is a floating system. But the system will not connect it to the earth, but this kind of installation compulsory earthing is required. So we are going to keep the system as a floating, but that doesn't mean we don't need a earth. Okay, earth is required. Earthing you have to follow as per the tan. But inside the rack, if you see considering the rack wise, when it what are the racks to be connected to the earth, there only we have a limitation. There only we are making our KFA BMC rack and a relay rack and CT rack. All three racks are floating. We don't want to do the earthing. Since our system is floating, we don't want to do the other two racks, relay rack and CT rack. It should be floating and it should not be earthed. And how we are making this EA is floating and why we are not connecting to the earth, there are some 5 parameters are there. We'll go one by one. The first is power supply. If you say power supply, we are taking 110 volt DC from the 110 volt DC from IPS, and when it is comes from the IPS, we'll be putting it into the surge protection device. So C class C surge protection device will be used, and after the surge protection device, it will goes to the DC-DC converter. In the DC-DC converter, it will be having the transformer isolation. So 110 volt DC-DC to 24 volt DC-DC we are converting. So for our side, if any surges comes, it has to cross the class C SPD, and it has to, and after that you have isolation of DC-DC converters. So in this way, any search comes, it will be reaching the earth through through this SPD. So now, if you are not making earth, so this way we cannot able to achieve this floating concept cannot be achieved. So our SPD is also to be connected to earth. So if you are not making the earth, then we cannot able to connect our SPD to earth, and we can indirectly we cannot make our system to floating. Okay, so this is the first point, and the second point, field gears. What are the field gears? Are there that field gears? What we are doing, that will be coming to the relay from the CTR relay rack. From the relay, you have a relay will be picking up, and relay contact will be using. So the relay isolation is there between all the field gears. So if at all any surge comes, it will be affecting the relays only. It will not be affecting the it will not be affecting our EP subrack. So this is the second point. But what we have to do, anyways, cables are coming from the outdoor, but we have to take the outdoor cable armor and the armor to be earthed. Armor we have to earth, but we should not earth the CT rack. CT rack should be floating. So this is the third one, and the fourth one you can see all our communications are optical communications. So we don't need any other converter or any other information to be converted. So if all are OFC, then there is no possibility of lightning coming into the OFC. That is the one of the point. This is the fourth point, and fifth point will be like in-house isolation. For example, from the ground, we will be providing the rubber beading here, so we anything cannot come from the ground, from the floor. And if this is the fifth one. In the fifth one more point is that if anything comes to the if the search comes in the rack, but it will not reaches the subrack. Between rack and subrack, we will be providing the polyoxide material, so that will be having the physical isolation will be there. If you keep the buzzer, and if you keep the buzzer between rack and our subrack, it will not have any continuity should not be there. So this is how these 5 points are making sure that we can able to maintain the floating system. So KFA BMC is a floating arrangements only. It required earthing for a SPD earthing and outdoor cable armor earthing. So for these two purposes, compulsory earthing is required. So earthing to be done as per the TAN, as per the RDSO TAN, but we should not connect the EP5 KFA BMC sub rack and KFA BMC rack, KFA BMC EA rack, and KFA relay rack and KFA BMC CT rack. CT racks, relay racks, and EA rack should not be connected to the earth. So this is the main important topic we want to understand, and further we'll go for the lightning protection. So this is our earthing plan. So this is done as per the RDSO TAN. So you see from our KFA BMC rack and FRMC's rack, these are the rack. It is not connected. It is not connected to earth. It is floating. And relay rack also see it is also floating. And CD rack also it is not connected. Only armor is connected. So similar way with our VDU as well as panel processor also. Panel process also to be done similar way only. And MTC also, PC also should not be connected. Only all the things will have a SPDs. That SPD should be connected to the earth. If you are not making the earth, then these SPDs cannot be connected to the earth. And the earthing arrangement, as a part of the outdoor first point, we are going to talk about the earth. So earth, you should have a type, class A type, SPD along with the protective enclosure shall be connected to the separate earth, shall be connected to the separate earth pit. So there should be a separate earth pit should be there. It should be the one or more. Okay, as per the TAN. And this earth pit shall be interconnected with the EA system, ring or perimeter earth system. So EA also will make on earth, and class A also will make on earth. This both earth, as per the TAN, it should be interconnected. So the ring earth for EA shall be done as per the proposal. So as per this proposal, you can able to do the ring earth. And this is our SPDs. So we are showing no our power surge production device. This is our SPDs. So this is our supply from IPS. So this is our SPDs. SPDs we are using it SPD, and it will have connection to the earth. And next is EA connectivity. EA connectivity is done, as I explained. EA connectivity is done as per the uh, OFC cables. In case of distributed architecture or centralized architecture with a different building, if the building is different, sorry, then it shall be the armored OFC cable. In the armored OFC cable also should be redundant and diversified OFC path shall be provided. You have to provide two cable, and both the cable should be in a different path, and it should not be in the same path. And OFC shall be terminated in the separate communication track in the central EA room. And OFC connectivity for the EA and EA subrack in case of centralized architecture in the same building, unshielded OFC can be used. For the same building, you can use unshielded OFC. Armor of the OFC should be earthed to the EBB at the entrance of the building, the centralized or distributed location. So this armor of the OFC cable, single mode OFC cable should be earthed. This is again one more point. And now will comes to the IPS room. So IPS room, from the IPS room to relay room, you have to provide from the IPS 2 to relay room, IPS 2 to IPS room to power room to SM room, power room to MTC room. So all the different rooms we have to provide the redundant supply. The two supply should be provided. First supply 110 volt DC and second supply 110 volt DC. These supplies shall be laid through 16 square mm copper cables. We should not use a single line cable and other cable as per the requirement from the OEM. We have to use only 16 square mm copper cables. So what is the you have different options are there when it comes to the IPS room. You have different options. Main IPS at central locations and the mini IPS at distributor locations with 110 volt DC supply extended to the distribution location from the central IPS by using the diversified path. When it goes from one room to one room, we are recommending all are recommending in a diversified path. It should be the two different path. And IPS at all location 230 AC supply is extended to the distributed location from the centralized equation to the diversified cable. The second option, first option is 110 volt, central one IPS and mini IPS will be there. Second option is 230 with all the location, and third option is 230 with auxiliary transformer. That's the third option, and the fourth one is chargers and battery concept. So either of one we have to follow, and the cable we have to use is 16 square cable, copper cable we have to use. And when it comes for the data logger networking, the data logger shall be networked from the station to the its central place. We are recommending to use only the OFC cables. So these are the outdoor point of view cabling requirement. Then we'll go into the indoor point of cabling requirement. So indoor point of view cable recommended PC between FMS to session master room to MTC room to electronic terminal subrack MMIF2 or PC. Armored OFC patch card, unarmored OFC patch card should be used with the necessary protections. So we have to use the unarmored OFC multi-mode OFC patch cards when it is connection between the MTC or operator video or session master room or EMMIF panel room. For OFC connectivity from EA logic subrack to the electronic subrack for the same PIO in same room, unarmored patch card can be used. From the logic subrack to EP5 subrack, we can use the unarmored multi-mode patch cards. But we have to provide the necessary protection, avoid the damage and the cut. Okay. This is the EA room connectivity. And another further information in the EA room. EA room, our EA, we have to provide 110 volt DC. We will take 110 volt DC from the IPS, and that will be given to the SPD. And the SPD, then it will go to the DC-DC converter. From the DC-DC converter, it will come to the. After that only, it will comes to the our IPU 6C card. So for this 110 volt DC shall be taken into two different paths. So redundant diversified path. For example, system one you have to converter. The converter will be configured for n+1 configuration. So the n+1 configuration will be used for the system one and its protocol converter. And similarly for system two, separate DC-DC converters will be there. So that is also designed with the n+1. So that will be used for system two power supply, logic subrack power supply, as well as the data logger connectivity. And the 24 volt DC supply for EA system. And remaining subrack. Now we have talked about only the logic subrack. Now after that there is a EP5 subrack and EMC subrack. So EP5 subrack, all the subrack power is connected through 110 to 24 volt DC-DC converter in n+1 manner. So in between this electronic terminal, there is IO looping supply is there. For that also we have to use the DC-DC converter, 24 volt DC-DC converter in n+1 configuration. So if it is, these are all for the distributor. This is common for distributed and centralized location. But the next point is only when it is comes to the distributed interlocking, you have to provide additional DC-DC power supply. Also, it is additional DC-DC converter to be provided in n+1 configuration for system one separate and system two separate for the multi-mode to single mode OFC converter. Multi-mode to single mode FRMCs I told no fiber redundant media converters. That converters we have to use for system one separate DC-DC converter, system two separate DC-DC converter, and 24 volt input from the this 24 volt input, 110 volt input and 24 volt input. It should not be mixed. It should not be mixed with 24 volt output. Output DC-DC converter, output, input, and NONC all should be very clear and it should be segregated properly. And all the power supply within the EA room shall be we can use 1.5 square mm, red and black for the identification. And separate SPD box for the communication track shall be ensured. That is a separate box should be in separate SPD search protection device should be installed for the communication track. So this 110 volt, it should not be taken in from the IPS. It should be taken from the there is a one more surge protection box will be there in the EA. So from there you have to tap it. And the SPD from the SPD to the EA earthing, it should not be more than 1.5 square mm. So we have to connect our surge protection device to the earth, and that earth should not be more than 1.5 square mm. For this connection, you can use the 60 square mm cable. 16 square mm or more than 4 square mm you can use it. ensure that whatever the cable routing we are doing, from the IPS to our EA rack, it should not be mixed with any other wiring. It should be very clean. And as per audio SOTAN, you see, you should not have any. You should not bring all the supply to FTOT rack. It should go directly to the individual room from IPS. For example, IPS to EA room, it should directly go. IPS to relay room, IPS to SM room, it should directly go. IPS to maintenance room, it should directly go. Some of the stations we have seen, all the supplies are brought to EA room, and from the EA room, it is distributed to individual rooms. That is wrong. That is not as per the TAN. So the TAN, what it is saying, in all the supplies should be taken it from the IPS room only. You cannot able to bring everything to relay room. From there, you cannot do. So that we have to ensure it here. And this DCC converter, it is having inbuilt DC health status contactor. Okay, that will not be communicated to, that will not be readed to, that should be readed directly to the ET502 and EBBs. Next is related to the EBB. In the EBB, in the EA room, shall be provided as per the audio SOTAN separately for the EA room, IPS room, and panel room at 300 and 500 mm from the floor by using the 25 into 3 mm copper strip. Copper strip you have to run the entire the room of these three rooms, different rooms. Compulsory for EA room. EA room compulsory we have to make it, and with this proper company proper specification. This is as per the audio SOTAN. Each of these to be connected separately to the perimeter ring. It should be connected to the perimeter ring. And there is a one more EVB we have to make it for a maintenance room also. And as we told, earthing of the cable, earthing of the armor cable on CTR rack shall be done in such a manner that the CTR should not get earthed. This is very much essential for Kyosan make EA, where we are not earthing our relay rack, EA rack to avoid the surge. However, it is also understand that CTR also having any leakage with the earthing system, cable shielding earthing by avoiding the appropriate installation material. So the CTR should be isolated, and the CTR to armor earth also should be isolated. And we should provide the proper isolation between the racks and walls and ladders. That is also, it is very much important. And cable drop. This is next. This is IO cable, power supply cable, and communication cable. If you see IO cable, all the IO cables are zero point 0.5 square mm, wide by square mm, red and black cables. And power supply cables, it starts from 1.5 square mm, 4.5 square mm, 10 square mm, and 16 square mm. So different cables we are using it for a different purpose. And communication cables I explained, multi-mode OFC patch cards, multi-mode cable, and single mode OFC patch cards and single mode OFC cables. This will be these are the cables we are using for our EA, KFA BMC EA. And data logger. Next is EA room. You have a data logger equipment. In the data logger equipment, if you see, you have to use a different cable, different wire for the data logger. We are recommending to use the yellow color wire, so that from the color itself we can identify that these are all related to the data logger functionality. So now we are saying monitor from the IPS only, not from the EA room. That is also another point. And there is an armored OFC patch card. It should be used. Unarmored OFC patch card should be used between the serial optical converter between EA subrack to data logger protocol. So EA logic subrack to data logger protocol converter, we have to use unarmored OFC patch card. So this is related with the data logger. And next we will go to the SM room. If you see SM room also you are having DC-DC converter. We have to design DC-DC converter plus N plus 1 separately for A video and separately for B video. And it should be housed in the suitable enclosures in the station master room. And 110 volt DC input super supply shall be taken it from the 110 volt DC bus bar of IPS. We have to take it from the IPS. You should not be taken from the relay room or some other room. And you have to provide the SPDs. SPDs also compulsory. We have to provide. So similarly, similar configuration for CCAP also. If you are having panel also, then you have to provide the separate DC-DC converter for the panel, and that one ton also you have to take it separately from the IPS. Now we will come to the maintainer MTC room. MTC room also should be designed with the separate 110 volt DC-DC converter, 110 volt to 24 volt DC-DC converter. It shall be designed with N plus 1 configuration, and DC-DC converter from supply should be taken it from the IPS directly with the SPDs. And now both VDU and MTC we are using monitors. So this monitor supply also should be done through the inverters. Now as per the new TAN we have to use the inverters, and with the inverters only we have to power up our monitors. There are two options are there: 24 to 110 230 volt inverter, or 110 to 230 volt inverter. So either of the one of the inverter we can able to use it. And FRMC we have told no fiber redundant media converter. That indication also to be shown in the video. And supply cables, any power supply cable should not mix it with the other cables. Monitor we have to install with the proper isolation. These are the main requirements. So then we'll go into the KFA BMC installation practice. So these are the rack erections. So we have to ensure that there is a space between the two rack for the EC maintenance. And EA rack and relay rack shall be erected as per the approved floor plan only. This is our sample erection. You can see like these are our KFA BMC rack 1, rack 2, rack 3. It's a double door rack, so it will be having a rubber beading inside, and with the rubber beading you can able to erect. And top of that you have to provide the isolator. From the isolator you have to put the ladder on the top. This is a EA rack erection. And you can see like there is a relay rack also we have erected with the tripod and tripod.
Excuse me,
Yes.
sir. One minute, sir. Sir, somebody's mic is actually background noise is coming. So all are requested to please keep their mic mute. Once again, I am requesting. मैं सभी से रिक्वेस्ट कर रहा हूँ कि प्लीज माइक अपना म्यूट कर लीजिए, कोई बैकग्राउंड नॉइज आ रहा है इसमें. Okay, thank you, sir. Please
Yes.
continue, sir.
Yes. So this is a rack erection of relay rack. Relay rack, if you see, relay racks will be erected with tripods, and after the tripod, you will be having the isolation we have to provide, and we should not earth this relay racks. This is sample relay rack erection, and this is a similarly we have to erect this one also, data logger also. And laddering arrangement. Laddering arrangement is the main element for cable routing and wiring. So the following things are very necessary when we are doing the ladder. The ladder should be isolated from the rack and the wall. From the rack also should be isolated. From the wall also it should be isolated. And by using the rubber isolator and or aluminum sheet, we can use either of them. So what is the ladder we are planning? Now we are planning two-step ladder. Like the first ladder we will be having a two trough, and the second ladder will be having a two trough. So according to the TAN, you have to segregate the input, output, power, and data logger. So as per the TAN, these four should be segregated in a different trough. So for any installation, these four trough should be available at any installation, any KFA installation or any EA installation. These four trough must be available, and these four trough shall be installed in a two-step ladder. The first step ladder you can have this input and output. The second step you can have power and data logger. And ladder support you have to give every 3 meters. We have to give the ladder support. Then only we'll be having a good mechanical strength. All the power cable, IO cable, and interconnection cable have a different ladders. We have to keep as much as possible. We have to keep it in a different ladder, and possible we have to in between the trough we have to give the 6-inch cap. And ladder at any cost we should not earth the ladder in our installation, or in our installation we should not earth the ladder, and the ladder arrangement shall be defined through the shortest and safest path at site. Ladder arrangement we have to make it should be short and it should be safer. So once the ladder arrangement is done, then proper size of rubber beading and other things should be selected properly and it should be used properly. So in the ladder is very much important when we are planning for cable routing and other things. So the ladder only decide how the cables are going inside the rack and how it is coming out from the rack and how it is interconnected between the rack and how it is interconnected between our relay rack and CD rack. So for all the purpose, this laddering is a very important point. This is going to decide entire our interlocking installation. So this is with the laddering arrangement. Next EA subrack. So for our EA subrack installation also we have a different equipment I explained. EA logic subrack, EP5 subrack, and zonal module, and splitter card, and watchdog timer, and all other relays. So these are all relays should be how we are going to install that we'll see. So this is a typical K rack. This is the typical Kyosan rack, front view and rear view. So, so this is a typical review, and this is the POI material I told, poly oxide material. So this will be installed before the rack, and the rack will be isolated completely. On top of that, only our sub rack will be erected, installed, so that it will not have any continuity to the rack itself. So this is a routing. You can see our KFA BMC EA. We have to follow this kind of routing only. So you have now if you see this KFA BMC rack, DC converters are installed. So 110 volt has to 110 volt DC has to enter inside one side, and 24 volt DC has to go to the other side. And we have to design like this 24 volt and 110 volt, and over it is getting mixing. So this is one of the very important routing principle. And in between this 24 volt and NC contact, this is also should be isolated properly, and this should not mixed with again 110. It should be separate one. And this 110 volt will connect it to the last row. Last row is completely 110, and remaining things it is all are 24. And these blue colors are our IO cables. So input output cables will be terminated in the top. So that is also isolated. So right side, if you see, this 110 volt DC is coming, and it will be routed till end. Okay, from there it will goes to the terminal, and from there it is distributed to the DC converter. From the right side, again it will go front side. From the back side to front side, we'll be having terminal for the different 24 volt terminals will be there. The terminals we have to connect. So this is the important routing when it is comes for the EI. So if you see typical KFA BMC EI racks will have minimum four to four trucks will be there. One trough is for 10 volt, and one trough is for 24 volt, and another trough is for input, another trough is for output. And one more trough will be there, if a smaller one, or it can be accommodated with the power for the patch cards. This is the main routing within the EA rack. Then we'll this is how the duct will be there. I also explained now trough. This is the A trough, B trough, C trough, D trough. So for both bore trough we can able to make. In this one of the trough we can able to bring this 24 volt, and another trough will be having with a input output terminals, and another one will have in the same one from the top only we'll be installing the logic subrack, this EP5 subrack. Bottom space we can use 24 volt, and 110 will be in a different trough, I told you, no? So 110 we should not mix. So this is how the routing is done inside the EA. And similarly, this is the actual photos you can see for the sample we have created. You can use the power 24 volt power in the top, and bottom you can use the patch cards. So patch card and power you can mix. It should not mix, but it should be segregated properly. But it can be used in the same trough. And this is our EPP subrack. For EPP subrack, 24 volt is coming from a different trough. You can see, and the patch cards are coming in a different entry. And this input, this is IO cables. This is coming. This is going in a separate trough, in the same trough only, but the path it is not mixing with any other cables. And this is the that is all with the EI, and we'll go to the relay rack. Relay rack also it should be very neat and clean. Now what we are deciding is, like whatever IO cables are our IO cables, which is from coming from our KFA BMC rack, that will be entering in the left side of the left side trough of the relay rack, and the CT rack and miscellaneous cable will be there in the right side. And similarly in the relay also, top and bottom, the top will be like your IO cables. IO cable will get down here, and the CTR cable will take it from the down. So the similar pattern we have to follow for relay rack also. So IO cable and CT cable is bit different, and the relay side also IO and CT from the EI through CT. So that is also differentiated. We are completely eliminating all the things. And one more request in this fire heat sensing cable, and we are not recommending to use a heat sensing cable either in our KFA BMC rack or EA rack. If at all you want to use, you can use it in the CT trough. CTR trough is there, no? In the trough you can use it. You should not, in any case, you should not mix with our EA supply. Since the heat sensing system is using the external 24 volt, again that is not the clean supply, and we are having all the supplies are clean, and that will have a mismatch between that will lead our system failure. That has happened in couple of the station now. And IO termination, relay rack cable routing and wiring. This is how the relay rack wiring will be there. This is IO. First is out. First is input, and second row is for output. C row is for the power supply positive, and D O is power supply negative. And after that, 6 rows are there. We can keep 6 rows of relays. So one row, 14 relays we can keep. 6 rows are there. 84 relays we can keep. Overall capacity for the relay rack is 120. So in that two relays we are giving one cap. By considering that 84 relays we can accommodate in one rack. This is the rack concept. In the rack routing also we explained. One side IO should be there, other side CT should be there, and the relay top side IO should be there, bottom side CT should be there. It should be properly segregated. This is a bar without relay we are explaining. And this is our relay room earthing arrangement requirement. So we have to provide this earthing, and it should be welded. It should not be bolt and nut. This earth cable, it is coming from SPD or it is coming from cable armor, it should be connected to EBB with weld, and we should not put a bolt and nut here. Always it should be welded. And further EA installation guidelines, we are following our Kyosan, we are following the OEM installation guidelines we have to follow, and we have to follow the RDSO pre-commission checklist. And apart from that, TAN also we are following 3012, 30007. These TANs we are following. And recently we are following the security TAN also. Cyber security TAN also we have started following it. And networking, as of such, there is no networking as of now. It is recorded for this, but the MTC we are doing networking. For example, if you see, this is the typical MTC networking we have done for NFR session, NFR zone. So Maligan is our the headquarters. From there, through we are using railnet, and we have created Alipur Duar, Kartigar, Rangia, Tinsukia, and these five subdivisions we have created, and below that we have connected these stations. So these are the station. The this many station you can able to see it from one place. From the Maligaon, you can able to see this all the station. It should be KFA BMC. All the interlocking should be done by KFA BMC Kyosan, and all can be networked to the central. And from the central place, you can able to see all the information. So for this, what is a cable requirement we were talking about from the station to main this zonal headquarters? You should have a railtel connection, or the dark OFC connection should be there. If it is there, then we can able to establish this network. So in this, we can use a different converters. Like if you want to, if you are giving E1, then E1 to Ethernet we can convert. Ethernet converter we are using. If you are giving the optical, then optical to Ethernet we can convert. Ethernet converter we can use. So this is depending upon the railways availability. If E1 is available, you can give the E1. If this is for the MTC networking I'm talking about. For the normal EA to EA, it should be Ethernet only. And one of the commission station we have taken, this SECR, Sakti, station name is Sakti, which is having 109 routes and 6 roads. So in that, we'll explain how many, there are 3 racks are there. You can see like different racks are there. In this rack, you can see like this is our EP5 sub rack, input output sub rack. In this input output sub rack will be connected in this trough. You can see the trough in the back side. In this picture, you can clearly see there are 2 different troughs are there. In this different troughs, this input cable and output cable is coming differently, and it is terminating. And similarly, this power patch cards, red colors, black colors are patch cards, multi-mode patch card, and input output cables are differently. It is going on. It is not getting mixed. So this is actual photos of the one commissioned station. And 110 volt AC is coming in the one side, and another side 110 volt 24 volt DC is coming in the other trough. So 110 volt and 124 volt, it will not mix. It will be coming in opposite directions. And 110 will be terminated in the back side, and 24 will be terminated in the front side. So again, it will be having that informations also. It is possible now, like 110 and 24 will not mix. We'll be designing in such a way that on 24 and 110 will not should not mix. And this is our logic subrack. So this is how the logic subrack will be. Finally, it will be looks, and it will be having all the necessary cards. If unused ports will be put with the dummy plates. And this is the backside view. This is a full. This is a full logic subrack used, and whenever the unused port will be used with the dummy plates. And this is the backside of EPP subrack. You can see the cables, routing, and other things from these photos. And this is how the DC-DC converters are connected with the EA. You can see like it is coming from top. 110 is coming from top, 24 is going from down, and this one is coming from the 24 side. So NONC and 24 will go down, and 110 is coming from the top. So the segregation itself in such a way that this left side 110 will come, it will connect it in the top, and the bottom will come. In the bottom will take 24 volt, and it will connect it to the right side. So this is how we are following the routing of the DC-DC converters. And this 24 will be 110 will be 110 volt will be terminated in the back side of the rack, and 24 will be terminated on the front side of the rack. If FMS is there, then FMS also will be terminated in the KFA BMC rack. Terminated, and the single mode fiber optical cable should be spliced, and the splicing cable should be connected to this FMS. And this FMS to our logic sub rack, we have to use the patch cards. And remain these input outputs are the copper cable, 0.5 square mm copper cables we can use, and here and all we can use 1.5 square mm copper cables. This is our relay rack. As I told, you can see this is the front view and this is the back view. So you can see there are two troughs are there, trough 1 and trough 2. This is the IO trough, and the other side is the CT trough. And in the relay also, top you will having a smaller trough and the bigger trough. The smaller trough is for the our system, the bigger trough is for the CT rack. So whichever is coming from CT rack or going to CT rack, it should go in this trough, and whichever coming from the EA, it should be available in this top trough, small trough. So this is how it is segregated. By doing the by allotting the smaller trough itself, we will come to know this is for the system, and this is for the CT. And this is a way IO cables and data logger cables. This is a data logger cable communication connection termination. So it will be terminated with a yellow color cable. And this will be our commissioned station SPD. This is how we are connected. Power supply, redundant power supply has been taken, and it is put on through like diode. This is our diode, and after that HRC fuse is there. After that it comes to the C class C SPD, and after that it goes to the EA supply. And this earth also is going down. Earth will be connected like this to the earth, to the room EBB. And this is the operator video wiring information. So there will be a two different embedded PCs will be there as per the audio so 10. So the two embedded PC will be powered up with the different DC-DC converter. So for a system operator video A will have a DC-DC separate DC-DC converter. For this, there separate 110 volt DC will come, 110 volt DC. From there, you will be having a SPD. From the SPD, it will be having a fuse. From the fuse, it is goes to the terminals. From the terminals, 110 will be coming in the top, 24 will be coming in the bottom, and the 24 will connect it to the PC. And PC from the system to from the PC, we will be installing PCI card as I explained. So this card is used to connect between the embedded PC to logic subrack through this optical multi-mode optical patch cards. So individual system will have an individual card, and individual card will have an individual connection to the individual systems. So this is for the system 1 and this is for the system 2. So both here also we have to make the earthing arrangement so that the SPD earth can be connected here. And it should not be screwed, and now here it is done screwed and thing, it should be welded. It should be welded like this. It should not be screwed. Screw should not be put. We should not put. This is a Sakti session video layout. Video layout will be looks like this. We can create a single monitor, multiple monitor, whatever the requirement we can give. As of now, we have done with 5 monitors. And this is our MTC PC. MTC PC also will be allotted with power will be taken from the IPS directly, and it will be terminated here, and from there it will goes to the SPD. From the SPD diode. After the diode, it will goes to the SPD. From the SPD, it will goes to the DC-DC converter. From the DC-DC converter, it will come to the embedded PC of the MTC. Again, it will show the Sakti, that's a particular station layout here. This is with the MTC PC. and from here only we can able to do the networking also. The same place we can add one more device. That device will take ethernet from the mtc, and that device will we have to connect to the device, and that device will convert that ethernet into optical re1, whichever railway is giving. Based on that it will connect, and from there it will goes to the headquarters. In the headquarters you will be having the, you will be again we have to reconvert whatever it is coming like ofc, it will be reconverted into ethernet, and from there again we will be providing one more pc. From the pc we can able to see all the line of sessions. So this is how the mtc comes. Then this additional cable requirement also is required, mtc networking part. And this is our earthing arrangement. The class A should be provided as per the RDS standard, and it should be connected to the one or two earth bits. Different earth bits should be, one or two earth bits should be connected, and that is different from our EA room earth. EA room perimeter earth or ring earth, it should be different from that, and both the earth should be interconnected. And when it is comes to the room, it should be individually connected, and it should be welded properly. So from our side, we hope we covered everything. We can have a QA section now.
Okay, thank you for a very informative presentation. And you can take the first from the chat box one by one.
Yes, sir. Schematic is followed by other EMA, but this is sir. They will take this. Okay, I'll share my screen again.